Hello students, Mr. Small here. As you can see, we're going to be talking about systems of linear equations. A system of linear equations is a set of two or more equations whose solution is an ordered pair that fits or matches both equations. We're going to be using the equation on your top left in standard form currently, and the equation on your top right, just two equations in this case. And actually for 8th grade math, we are just using two equations, so we are not going to go into 3, 4, or more than that. So for today's example, we will just be using those two, as I said. Now, one thing to note before I go further with this is, though a system could have just one solution, where the one ordered pair, the one that fits or matches, is the solution itself, and that happens with intersecting lines, you could also have two other types of systems where you've got no solution, or in this case, zero solutions. And you also have coincidence systems. In the zero solutions case, you have no solution. No ordered pair fits because these lines are parallel, which means, of course, they have the same slope but different y-intercepts when graphed. A coincidence system has infinitely many solutions, and that happens with identical linear equations. That is, when you're comparing them in the same form. Thus, they have the same slope and the same y-intercept. Now, today, however, we are just going to be dealing with ones that are in one solution, so just kind of keep that in mind as we go. So we're going to be solving different equations with one solution. Okay, students, so here's what we're going to do. We're going to make a table to start here to solve these. Okay, to solve these systems. And really, we're okay on this one over here so far. We're in slope-intercept form, so we're good. We've got the m, which is -3/1, which is the slope, that is, and then we've got the y-intercept, which is the ordered pair 0, 8, but this guy is a little bit pesky. We need to turn him into from standard form into slope-intercept form. So I'm just going to do that quickly. I rewrite this. I am going to take away 4x from both sides. Can't combine unlike terms, remember, so this ends up being -6 minus 4x. I'm looking for a coefficient of +1 for the y, so I divide out the current coefficient of -2, and then I get y equals 3 plus 2x. So if I just make it nice and neat here, sorry, 3x, it's a little goof, Mr. Small. And we've got our y equals 2x plus 3. Now we've got two equations in slope-intercept form. We're good to go. Here's my table, which, by the way, this table here is going to correspond to this equation. Okay, this table here is going to correspond to this guy. So what I'm going to do is make the exact same x, or I'm going to, just whatever, make it up and plug it in to each equation, and what I'm looking for is when the same y appears. So if I do 0 down this equation, that's 3 for the y. If I do 0 up here, that is 8. Let me just do 1 down here. 1 times 2 is 2 plus 3 is 5. If you do 1 up here, that's -3. Plus 8 is, holy cow, 5. I found it. Now, obviously, I contrived this example to make it kind of that way. 1, 5, then, is the solution for this ordered pair, or this equation, this system of linear equations. Awesome. Okay, so we already solved this equation, but I want you to see how it can be done what we call algebraically. Now, this is Mr. Small's preferred method. It's a little tricky, though. Okay, so let's remember the equation that was in standard form. This one was actually y equals 2x plus 3. So what we have here is y equals 2x plus 3 and y equals -3x plus 8 as our system. Now, one thing that's pretty neat here is if you notice, both equations are equal to y. I should actually say that the expression 2x plus 3 is equal to y, and so is the expression -3x plus 8. So if two things equal y, then guess what? They actually can equal each other. So the first thing is, for solving algebraically, you get the equations into slope-intercept form, and since they both equal y, you can set them equal to each other, which then enables you to solve for the x portion of the ordered pair. So what we're going to do here is collect the variable terms onto one side. And this is just reviewing the simple solving of linear equations here, folks. Now I will collect the constants onto the other side, and then I will identify the coefficient and divide by it. And I now have x is equal to 1, which we already know this, by the way, but now we can solve for y. So we know that y equals a couple of these, so we'll just pick one of them. So if y equals 2x plus 3, the reason we can solve for y is we now have an x. So I just plug in my x there, and now I have y is equal to 2 plus 3, y is equal to 5. There is the ordered pair that is the solution again. It is 1, 5. Algebraically is a good way to do this. It is tricky. Again, what you want to do is put them in slope-intercept form each, set them equal, set the expressions that aren't y, that is, equal to each other because they both equal y. Then you solve for x, then you solve for y using x, and you got the ordered pair, and you're done. Now lastly here, we can solve it obviously with the graph. This is kind of where you start to see what I mean by matching ordered pairs, or where they meet. Different language you'll hear for this. Y equals 2x plus 3 was this one, if I remember correctly. So we're going to try to find the matching ordered pair. So here's what we're going to do. I'm going to actually graph this one first, and I'm going to plot its ordered pair, boink, at plus 8. I'm beginning by using the y-intercept, and then I'm going to move, if you remember this language, according to the slope, which would be down 1, 2, okay, down 1, 2, 3 over 1. I could just keep moving, 1, 2, 3 over 1, 1, 2, 3 over 1. Oh man, it's kind of sloppy. Mr. Small, let's clean this up a little bit. Yoink, yoink, yoink. Okay, and if I had a straight edge on this program, I would use it, of course, folks. There is my graph of y equals negative 3x plus 8. I am now going to graph this other one. I'm going to start by we begin the ordered pair 0, 3, and then I'm going to move up 2 over 1, boink, up 2 over 1, boink. I can also move down 2 over 1, yoink, down 2 over 1, and there you go. You've seen it. This is where they intersect or meet at this ordered pair right here, which of course we know is 1, 5. So that, students, is a thorough review of how to do systems of linear equations, either with a table, algebraically, or with a graph. Again, I would recommend the algebraic way as a surefire way to do any sort of equations, whether they are large ones or whatever, because you don't have to worry about fitting it on a graph. You don't have to worry about trying forever with ordered pairs to try to find them. I hope you've enjoyed Mr. Small's systems of linear equation review. Have a wonderful day.